All right, we were start talking about Precambrian time. Um, Remember, this is like a super epoch because it covers billions upon billions of years. All right, so I was talking about the Hadean. All right, let's go back just a little bit just to see where we're at. Okay, so the Hadean is that's the from the beginning of the Earth. This is a period where um, there's this what's called late heavy bombardment. The moon is actually formed from a collision. There's lots of activity still going on in the formation of the solar system. Um, and so this, most of this time, we believe that the Earth was molten, right? The rocks were melted. Um, or they were already they weren't even rocks yet. They were just liquid. All right, so as time goes on, right? This is the first billion years or so of the Earth. The Earth begins to cool, and this is the Archean. Okay, so the Archean is the middle of the Precambrian. So again, this is billions of years, or well, roughly, yeah, this is over a billion years. And so the Earth begins to cool, and somehow, again, we don't know how this happens, but life emerges. Okay, so let's see. So this is what's commonly called the cyanobacteria. Um, these are one-celled creatures that the biggest thing that happens during that time, of course, is they somehow invent this idea or this ability to turn sunlight and carbon dioxide and water into sugars, right? That of course that's photosynthesis, and as a byproduct of photosynthesis, um, there is O2 molecules, like the oxygen that we breathe, right? So O2 molecules, and also, of course, there's in the atmosphere. Um, well, at first, the atmosphere does not have free O2. Even when these cyanobacteria start creating it, it almost immediately the oxygen gets dissolved and dissolves into the water, right, into the oceans, right. So, and in fact, we have evidence of that during this middle Precambrian time. Um, what was it called? Sorry, this Arcanian period. Um, so the evidence of that is the water. Within the water, of course, there is dissolved iron. Here, let's see if there's a. All right, so during the Precambrian time, there are these things called stromatolites. That basically this is the the blue green algae that is converting the very rich carbon dioxide atmosphere. That was what most of the early Earth's atmosphere was composed of carbon dioxide, and so it's turning that in and water vapor into oxygen. All right, so within the water, there's iron deposits, and the iron is dissolved in the water. But then, as oxygen gets dissolved in the water, the iron and the oxygen will go through a chemical change. And basically, it exactly what happens to iron nowadays is when iron encounters oxygen, it rusts, right? That's what happens, and that's been going on for a very very long time. All right, let's get a quick picture of that. Here, let's see. I don't think it's. Let's see. Da-da-da. So. Uh, let's see. As nitrogen increases. Oh, I thought they'd have a picture. So, hold on, I'll find a picture. All right, and so this is the picture that I was looking for. So this is during the Precambrian, the middle era, the Archean. The oxygen that is produced by these stromatolites gets dissolved in the water, but then that has a chemical reaction with the iron that's already dissolved in the water, and you have this banded iron forming in the oceans. All right, so that we find this, we found this a long time ago. In fact, we use this iron ore. We, being humans, of course, have been using this iron ore for a very long time. All right, let's go back to this slide right here. Current slide. There we go. All right, so stromatolites again. That's what's producing these produce the oxygen. During photosynthesis. Let's see. All right. So and during this middle time, there is a little bit of a diversity. There you start to see multicellular organisms. There's very limited fossil evidence of this, but we do have some fossil evidence of this. So this is really towards the end of the Precambrian. All right, so let's go through the atmosphere. At first, we think that the atmosphere was primarily hydrogen and helium because that's really what formed the sun. And then the secondary atmosphere comes from volcanic outgassing. There's lots and lots of carbon dioxide and water vapor that comes out of volcanoes, and that's true today, right? That still happens anytime there's volcanic activity. There's carbon dioxide and water. All right, and then of course over time the water condenses to form clouds and then rain, and then eventually you get enough of it to form the oceans. By the way, we don't think that all the water came from the earth. We think that during the late heavy bombardment, there was lots and lots of water that was deposited by material from out beyond Mars, right? Because that material that's out beyond Mars is very rich in ice, in water ice, as a matter of fact. And so when it fell onto Earth, it deposited tremendous amounts of water onto the Earth. Because you can't really account for all the water that is found on the Earth with just if we look at simulations of the material that is the distance that the Earth is from the sun, you don't get that much water, and so we feel that during the late heavy bombardment, when Jupiter was moving around, it wasn't in its current place. It caused a great number of asteroids and other material in the early solar system to head towards the sun, and of course, some of that material hit the Earth and basically enriched the amount of water. All right. So anyhow, let's see what else. In the third atmosphere, you get the removal of carbon dioxide from the rocks. That is that's taking place. That's an interaction between life forms, plant life, right? I mean, we're talking about plant life, let's see. And nitrogen begins to. So as you lose more and more carbon dioxide, due to plant life, you get more and more nitrogen, right? Which of course right now, the modern Earth is more than 70% of the atmosphere is nitrogen. about 20% of the atmosphere is oxygen. These are the O2 molecules that you and I can breathe. And then, of course, also O3 was coming into being as well. Whenever you're creating O2, a small fraction of them of the O2 reaction will create O3, and O3 is it tends to be lighter. It's kind of a strange idea, but it ends up in the upper atmosphere, and that's actually what we call ozone. O3 is ozone. All right, so let's see. What is this? The development of free oxygen was crucial to the emergence of life, because this led to the formation of so the ozone. Well, this is the main one. The ozone O3, which helps screen the Earth from harmful incoming ultraviolet. All right, let's see. Ozone primitive. No, that's not true. Oceans were life. See, the life in the oceans were pretty. If they were underneath the water, they were pretty much protected by ultraviolet. The life that ends up on land needed to be protected, but from ultraviolet radiation that's coming down from the sun all the time, and that's what ozone does. Ozone will block it. All right, so let's see. The evolution of cyanobacteria. Remember, that's the blue-green algae helped oxygen escape to the atmosphere by keeping the carbon expelling the oxygen, photosynthesis, the releasing it from carbon dioxide. Yeah, actually, I think all of the above is true. Yeah. All right. All right. So we have yeah. Here, let's go back just a little bit. All right. So during this time of, we were just talking about the Archean. This particular eon, and then comes the eon right before this Paleozoic. Okay, so this is the Proterozoic. Okay, so during that time, the Earth is cooled, has a nice surface, and it begins to form. It starts to approach the more like the modern atmosphere. Of course, it has a long way to go before that happens. But during this time, there is a sudden change, and they call that the Cambrian period. Okay, so this is during the era of the Paleozoic. Okay, so during the Paleozoic, we're going to break this into different periods. Okay, so we have these 6 periods. So the Cambrian, the big thing that happens during the Cambrian is all of a sudden, this is taking place starting about 543 million years ago. Remember, MA stands for million years ago. There's this explosion of life, and there's all sorts of life forms that come into being, and that's often called the Cambrian explosion. Okay, so let's get back into that. All right, so we just covered that. All right, so here we go. This is the Paleozoic era. All right, so the Cambrian. Well, I just want to talk a little bit about each one of these. Okay, so just try to get some what happened during each of these these are periods, right? So these are called periods. All right, and so they're characterized by changes in life forms, the fossils. We get a lot more information because there's fossils with hardened body parts that will actually fossilize much better than during the Precambrian era. Okay, so again, there's this huge explosion, this great diversification of life.